We're going to use separation of variables to solve the differential equation 8 dy dx is equal to minus xy squared. And again, the first step is to multiply both sides by dx. So that gives us 8 dy is equal to minus xy squared dx. Now I'm going to do two things. I'm going to divide both sides by 8 and by y squared, and when I do that, I have 1 over y squared dy is equal to minus x over 8 dx. And now we integrate both sides. I can rewrite a little bit. 1 over y squared becomes y to the minus 2 dy. And on the right-hand side, I can pull out the minus 1 over 8. So then I'm just integrating x dx. So now on the left-hand side, my antiderivative is y to the minus 1, and the whole thing is negative. And on the right-hand side, I have minus 1/8, and then x squared over 2. And then I get my plus c. So I can clean that up a little bit. That gives me minus 1 over y is equal to minus 1 over 16 times x squared plus c. Since both sides are negative, I can make it positive, multiplying the whole thing by minus 1. And the plus c here, it's an arbitrary constant. I'm not going to bother changing the sign over there. So now I still need to solve for y. So when I solve for y, I have 1 over y is equal to x squared over 16 plus c. I can take the reciprocal on both sides and get y over 1 is equal to 1 over x squared over 16 plus c. And bringing that on a common denominator, I have 1 over x squared plus 16 c divided by 16, but that gives me y is equal to 16 divided by x squared plus, I'm going to call 16c equal to d, just to make my life a little bit easier. They're just arbitrary constants, so I'm okay here. So here's my solution with d as an arbitrary constant, and we are supposed to solve the initial condition, or solve the differential equation subject to the initial condition y of 0 equals 2. And so we can do that by saying 2 is equal to 16 divided by 2 squared plus d. And no, what am I doing? I have x is equal to 0 and y is equal to 2. So of course, instead I have 2, that was correct, is equal to 16 divided by 0 squared plus d. That's better. And so 2 is equal to 16 over d. That means that d is 8. And now I can find my final solution as y is equal to 16 divided by x squared plus 8. And that is my final solution. We were also asked to draw what this function would look like in our slope field, and our initial condition again was y of 0 equals 2. So x equals 0, y is equal to 2. We have to go through that point, and if I follow the slopes carefully, I get something like this. Doesn't look that great, but you can do it more carefully on your copy.